Today's video is about using Microsoft Phi AI Vision multimodal models for vision question answering and image analysis. Imagine an AI application that doesn't just see an image, but truly understands it. What if you could ask any question about a picture and get a detailed and insightful answer? From what objects are in the scene to where was this photo taken, and even what are the emotions on their faces? That's the power of multimodal AI, and today we're diving deep into the fascinating world of VQA. In this video, we're going to explore how Microsoft Phi AI Vision models from Huggingface are revolutionizing the way we interact with images. We'll be focusing on how vision models can perform powerful image analysis and precise object detection, but also how they can answer your questions about the images, just like a human would. We're not just talking about simple image recognition here. We're talking about AI that can understand complex scenes, identify relationships between objects, and even infer the context and meaning of a visual. We'll show you how this works from the underlying technology to practical examples you can try yourself. The results are impressive. Whether you're a developer, a researcher, or just someone fascinated by the cutting edge of AI, this video will give you a clear understanding of how these powerful technologies are transforming the way we interact with the visual world. So let's jump right in and explore the incredible capabilities of multimodal vision AI. We'll cover everything from downloading the model and setting up the necessary environment to running the Python code that will show just how it works. I'll also give you some practical examples so you can see how accurate and efficient this model is. First, we will set up a Python environment for our application using VS Code and Conda. See our previous video for more details on how to get started with these applications, link in the description below. Hint, when you open Visual Studio Code, be sure to run as an administrator to allow access to the cache directory you will be using later. We start by creating a new environment using Conda, naming it Phi Vision. We use Conda Forge as the source for our packages, as it has a large selection of packages and versions. Next, we activate or start up the environment. Then, we install a few packages, including Pillow for image processing and Huggingface Hub for downloading our model locally. We have an NVIDIA GPU card on our PC, so we will install the GPU or CUDA version of Torch using pip. This command will set up the 2.6 version from the PyTorch repo. Then we use pip to install Transformers version 4.40.2. Other versions of this library have compatibility issues, so make sure you get this version. Installing the Flash Attention library will help speed up the model. Our code starts with some import statements. We need to convert the image file into something the model understands. We will use the Pillow library for this. We also are using pre-trained models from Huggingface, so we include these two Transformers functions. If you need to convert a PDF into an image, this library can help with that. The MyTimer module is included in the repo for this demo. It is used for benchmarking runtimes. This is the function decorator we use for including the timer module. Here we have defined a function named runModel that takes in 3 parameters, including the model we will be using with the default value that corresponds to the Huggingface model name, and then the images and messages to use in the inference. The model we will be using today is the Phi 3.5 Vision version, which is around 8 gigs in size. This model is fully capable of handling the images we will be processing. We use this class from the Transformers library. This class simplifies the process of using a pre-trained model. The class needs a model name, device type, attention setting, and since we are using custom code in this model, it also needs the trust remote code to be set to true. The auto processor loads the data preprocessor from our model. This processor helps with the image manipulation, extracting features, and tokenizing text. We pass in the model name, number of crops to use for the images, and the trust statement again. This next method will format the messages into the format expected by our model, applying our role and content template. Then we process the prompt in images and move the model to the GPU. It will return PyTorch tensors. We set the number of new tokens for the model to generate and set the sampling flag to false. Now, we generate the inference output from the model, passing in our inputs and arguments. When the model is finished, we need to clean up the response and convert it back into human-readable format. Finally, we print the response. Before we run the code, this is where the files for the models we download and run will be stored. To delete one, just delete the folder here. We see the model we will be using today has already been downloaded. This is the GPU card we will be testing with today. It is an NVIDIA 4060 with 8 gigabytes of memory. We will be running 3 different image vision tests today to demonstrate some of the capabilities of this model. First, we load a driver's license and ask for some details about the document. This is what the image looks like. It has a few different colors and sizes of fonts and a few images. The second test is with a deck of slides about regression models in PDF format. This model doesn't take PDFs directly, so we convert the pages into separate images using the PDF to images function from above. Here we ask for a summary of the slides. This is what the regression document looks like. It has 15 pages of slides. The final test is with the first 2 pages of the U.S. Declaration of Independence. We ask for the purpose and include a trick question. The author is not actually included on the document, but this fact is in the general pool of knowledge that the model should be trained on. Let's run this and see how well it performs. The first question took 30 seconds and looks correct. This is a sample Pennsylvania driver's license, and the expiration year is correct. This would be good for document identification and pulling information off of those documents. The next one takes a little bit longer, around 3 minutes. This is because it had to process 5 images this time. Looking at the document, the summary looks accurate. This would be useful for a situation where you didn't have time to read a large document, but wanted a quick summary instead. The last test took 48 seconds, and the answer from the model looks fine. It even got the author's name correct, for at least one of the many authors. So that wraps up our look at Phi-3 Vision's impressive capabilities with question answering, object detection, and image analysis. We've seen how it can understand and interpret visual data in a useful and intuitive way. This opens up a ton of possibilities for automation, accessibility, and creative applications. Now it's your turn to explore and see what you can build with it. Okay, that's all we have for today. Thanks for watching our video. As always, questions and comments are welcome. See you next time.